Hello, today we're going to talk about limiting reagents. And a limiting reagent is going to be the substance, the reactant, that limits or determines the amount of product that can be made. So if you have a friend coming over and you both want a peanut butter sandwich, you have a whole entire jar of peanut butter, but you only have 3 slices of bread. So are you going to be able to make 2 whole peanut butter sandwiches? No. Why? You're going to run out of bread. So the bread would be your limiting reagent. It's going to be the reactant that is used up first. And the peanut butter would be your excess reagent. You have extra. You have the whole jar of peanut butter there. So when we do these limiting reagent problems, you're going to calculate the substance, what you need, using stoichiometry, and compare that with what was given to you in the problem, the same substance. They're going to give you 2 values to start with. It does not matter which one you pick. Everybody's going to come out with the same answer. If you need more than what you have been given, then that substance is going to be the limiting reagent. So if you need less than what you have been given, the other substance is going to be the limiting reagent. We can also think of this in money terms. So I'll show you in this example. Suppose you have 6.70 moles of sodium reacting with 3.20 moles of chlorine. You need to make sure your reaction is balanced, which in this case it is not. So we're going to go ahead and balance that. And that means we're going to have 2 and a 2 here. Okay, again, they're giving us 2 reactants. It doesn't matter which one you start with. You're going to be solving for the other reactant so that you can compare your value to what's been given to you in the problem. So I'll do it both ways to show you. You don't have to do it both ways. Everybody's going to get the same answer. So 6.70 mole of sodium is what we're going to start with. And we're going to try and get to moles of chlorine here. So since we have moles and we're going to moles, we're just going to use our mole ratio from the balanced equation. So chlorine here has a coefficient of 1, and sodium has a coefficient of 2. And since that's what we're trying to find, you're just going to do the math. So 6.70 divided by 2 means you're going to have 3.35 moles of chlorine. And this is what you need. Okay, so you need 3.35 moles. Well, how much chlorine did they give you? They gave you 3.20 moles. So think of this in terms of purchasing an item. The item costs $3.35. You only have $3.20. Do you have enough? No. And if the answer is no, then that substance is your limiting reagent. Okay? So let's say that you started with the other reactant, which is the 3.20 moles of chlorine. So now that you've started with the chlorine, you're going to try and get 2 moles of sodium to compare with what they've given you in the problem. So moles of sodium is now going to go in the numerator. Coefficient is 2. And the moles of chlorine is going to go in the denominator, and that has a coefficient of 1. So 3.20 times 2 is going to give you 6.40 moles of sodium. So this is how much sodium you need. And they gave you 6.7. So the item costs $6.40. You have $6.70. Do you have enough to purchase that item? Yes. If the answer is yes, then the other substance is your limiting reagent. So you can see that you're going to get the same answer either way. It just depends on which one you start with. If your need is greater than your given, that is your limiting reagent. So the 3.35 was our need, and it is greater than our given. 3.20 was our given. So that means that substance, the chlorine, is our limiting reagent. If your need is less, so we needed 6.40 moles of sodium, that's our need. If your need is less than your given, 6.70 mole of sodium given, then the other substance is your limiting reagent. That is, again, the chlorine. So either way, doesn't matter what you start with, everybody's going to come to the same conclusion as to what your limiting reagent is going to be. Okay, so let's look at this one. Try it again. We're going to determine the limiting reagent when 4.10 grams of potassium reacts with 6.08 grams of oxygen. Check your reaction. This one's not balanced, so we're going to have to balance. So we have 2 oxygen here. That means we're going to need 2 here. That makes 4 potassium, so you're going to have to put a 4 there. All right, so let's just start with the potassium. It's first in the list. So 4.10 grams of potassium. Now, because you have grams, grams always has to be turned into moles. So 1 mole of potassium. And potassium weighs 39. You're going to have to use your mole ratio. Since we started with potassium, we're going to be trying to find oxygen here. So that means the coefficient from the balanced equation, moles of oxygen, is going to go in the numerator. And the 4 mole of potassium is going to go in the denominator. And then we don't want moles. We're going to want grams because we're going to have to compare units here. So grams of oxygen is going to go in the numerator. Molecular mass is always opposite 1 mole. Molecular mass of oxygen is going to be 32 grams. So let's do the math. 4.10 divided by 39 divided by 4. Times 32. Sig figs are going to be 3. So you get 0.841 grams of O2. And again, this is what you need. And if we look, this is what we have been given. So you need essentially 84 cents. You have $6. Do you have enough? Yes. So is oxygen your limiting reagent? No, because you have enough. That means that potassium is going to be your limiting reagent. Okay?